Alright, in section 6.7 we finally learned about the imaginary number I. And what I is equal to is the square root of -1. And if we were square both sides, we would find that I squared is equal to -1. These are kind of definitions that we need to remember. So let's look at some problems and see how we have to look at them, because there's a few little tricky things about some of these that can get you into trouble if you're not careful. If you look at the square root of 81, what we're going to do is we're going to look at that as the square root of -1 times 81. And then if you want to, this is how our thinking goes, we split that up into the square root of -1 times the square root of 81. Well, what is the square root of -1? It is I. That was how we defined it. We said anytime we saw that, we're just going to call it I. It's just somebody made that definition. It's not like I can get it to equal I or something. We say it's equal to I. We define it that way. The square root of 81 is 9, so what I get here is 9i. So that's my answer, 9i. And be careful, just because there's some negatives around doesn't mean they make positives. Look at number 4. You got -4, and then we're going to look at this as the square root of -1 times 36. Well, we can say that's -4 times the square root of -1 times the square root of 36. Well, that's equal to -4 times, now the square root of -1 is I, and the square root of 36 is 6, so this ends up being -24i when we're done. So you don't always, you got to be really careful with this not to think, oh, two negatives make a positive or something like that. You've got to be very, very methodical in your thinking as you go through these things. Now, what about something like number 9? Well, you go, okay, you can multiply, you're multiplying here, so 2 times 3 is 6, and I times I is I squared. But what is I squared? Oh, look up here. I squared is -1, so this ends up being -6. Now, this is the one that usually gets people if something's going to mess them up here. When I'm multiplying these two things, I need to simplify each one of them first. Think of this as -1 times 5 under the first radical, and -10 is -1 times 10. And then think about it this way. Split them up. That's the square root of -1 times the square root of 5 times the square root of -1 times the square root of 10. Well, the square root of -1 is I, and you got the square root of 5. The square root of -1 again is I, and you got the square root of 10. Now you can see that you got I times I is I squared, and under the radical, let's write 5 times 10. Let's combine those. Well, I squared is -1, and then under the radical, that's a 50. Let's see, but we can simplify 50. That's 25 times 2. 25 is the biggest square that goes into 50. So we end up with -1, and the square root of 25 is 5. And then a square root of 2, and then -1 times 5 is -5 square roots of 2. Here's what you don't want to do. This is the correct way, okay? This is the correct answer. Here's what you don't want to do. You don't want to say, oh, I can just multiply -5 times -10 there, and I'll get a positive 50, and my answer is 5 square roots of 2. No, that's not right. That is the biggest mistake people make with these, is trying to multiply, combine two negative radicals and put it in there. You have to do it this way. You have to look at each one and take the I out of each one. Usually what happens, you end up with a negative number if you've got an I under, or negative under two radicals. It ends up being a negative, and that's kind of confusing. That's why you have to follow this meticulous way of thinking with a problem like number 13. Okay, what about 17 then? It's -I squared. That means there's two copies of -I. Well, a negative times a negative is a positive, and I times I is I squared. And what is I squared? Oh, it's just -1. On 21, you got to remember that if you've got the square on the outside of the bracket, you got to square everything in the bracket. So the square root, let's make that a -1, okay? The square root of a -1 squared. I'm just going to do it that way, okay? And then you got I squared. Then you got the square root of 3 squared. You got to kind of think like this. Well, the -1 squared is just a 1. I squared is -1. And then the square root of 3 squared is just 3. So 1 times -1 is -1 times 3 is -3. All right, what about this, negative 2 over I? Well, you're not supposed to have an I in the denominator, so to get rid of it, if I had another I, that would make I times I is I squared, which would be negative 1. But if I multiply the denominator by I got to multiply the numerator by I. So negative 2 times I is negative 2I, and a negative divided by a negative is a positive 2I. All right, on something like this, we want to get rid of the radical and the I in the denominator. So we're going to go, okay, let's write it. I need another copy of square root of 6 to get rid of that because that's a no-no, and then the I is also a no-no. So what I'm going to multiply the numerator and the denominator by is I square roots of 6. Let's take care of the denominator first. You get 2 times I squared, and square root of 6 times square root of 6 is 6. That's going to be 12I squared, but I squared is negative 1, so that's just a negative 12 in the denominator. Now let's go look at the numerator. All right, we've got, let's see, square root of 18, we got an I, and then we could put the 18 times 6 underneath the radical. Now what I'm going to do is I'm going to keep up with the I, and I'm going to go ahead and just prime factor 18 is 9 times 2, so that's 3 times 3 times 2, and then 6 is 2 times 3, so I'll put the factors of 6 in a different color just so you can see where there's that break. Alright, so we got an I on the outside still. We got a pair of 3's and a pair of 2's, so we can take a 3 out front and a 2 out front, and we'll have a 3 left inside. So on the outside we have 3 times 2, which is 6, times I square root of 3. So now let's look at this. We can reduce this. On the outside of the radical, 6 goes into 6 one time and 6 goes into 12 twice. So let me just put the negative up,